Hello again. In this video, we are going to learn how to do a simulation for a diode using OrCAD Pspice. As usual, here what you see on your background is the Pspice. That is the platform that we are going to use the simulation. So before that, let me slightly explain this activity. So we all know that this is the circuit symbol for a diode. So the idea of this circuit symbol is that there's an arrowhead. So that means it allows current to pass towards your right, and it blocks current coming from the other side. So it's something like a non-written value. The one of the sides of this one we call this side actually we call this is anode, and the other side we call cathode. When you physically look at the diode, usually for most of the diodes we have cylindrical shape, and then there is a line. So that line basically represents this line, and that is the cathode. Since we are talking about junction diode, so it's a PN junction. This is how it works. Now in this activity, what we are trying to do is how voltage and current behave across a junction diode. So that is what we are going to see. So in order to see that theoretically, so our x-axis is voltage and the y-axis the current. We always measure voltage at anode with respect to the cathode. So that is this voltage here. So I will put it as VD. So just for the clarity. So this is a potential drop across the diode. So we measure voltage at anode with respect to the cathode. And then I is the current through the diode. So I'll put ID just to make it clear. So when anode voltage is positive compared to cathode voltage, we call it a forward bias case. And if we increase the voltage, we will observe something like this. So after that, it will go with a slight line. And we all know what the meaning of this line is. So this line is kind of giving us some sort of resistance. So you can see like as your voltage is increasing, current is slightly increasing. And now when it comes to reverse bias, extremely small current flows through the diode. Negative side of the this gap is extremely small. So it's a leakage current is very small. All right. So hope I have given you enough background. So now I'm going to discuss how to do the simulation. I have already started a new project on Pspice, and I'm going to put place part, and I'm going to put a resistor first. I have my resistor, then I'll put a diode. I will use maybe 1N4148 diode. I need a power supply. I do VDC for that. I place my power supply here. Now we all know that for OrCAD, definitely we need to have a reference, the ground. So by pressing G, you can bring ground window here. I'll pick 0 caps in, put it here. So basically all necessary stuffs I have now. Now I want to do the wiring. I'll use W key for wiring. So now my mouse pointer is changed to wiring mode. I'm going to wire them. To vary this one, so that is my V1 source. I need to vary the voltage source. So as I vary the voltage source, I expect to measure this voltage across this diode and the current through this diode in this simulation. So basically I will start with minus voltage and change it to another voltage and do the measurement. So if I do bias point analysis, I can fix this voltage to a certain value and do the bias point analysis. We can do it, of course, in that way, but that is not the case. When we have the DC sweep, we can easily do DC sweep. We can sweep this V1 voltage from some negative value to some positive value while doing the measurement in every node. So I'm going to start new profile. So I'll put diode, so you can pick any name there. And in the simulation profile type, so I'll pick DC sweep. So you can see here, you can do primary sweep and secondary sweep, so that we will do a different video. So the sweeping I can do sweep any of these. So here I'm going to use voltage source. I'm going to sweep the voltage. So the source name is V1 in this case. So I put V1, and then my starting value, maybe I'll put minus 10 volts, and end value, maybe I'll put plus 10 volts. An increment, the step size, I will pick it as 0.01. So it's very small increment, and I'm picking linear. Now, if I run the simulation, all the savings will be recorded. However, you will not be able to see them as a graph. Now here you can see Spice AD light is loaded, but you don't see any graphs as you expected. So this axis is voltage V1, so it's varying from minus volt to plus volt, and there are no any traces added. So I will add trace from this one. So I'll pick this button, add trace, and click it. So from here I can pick any of these sources. So even I can remove these some of the things, so that I can easily see things are available. This is how voltage varies. So when voltage source is changing from minus 10 to plus 10, and the potential across the diode varies like this. But this is not what we want. What we want, the VI characteristic curve. So therefore, I'm going to remove this one. So I can select and simply delete these traces, and I'm going to add. So in y-axis, what I want is the current through the diode. So I'll pick current through the diode. So now here I'm going to select currents and remove voltages. So it's easily I can see the current. So I'll pick current through the diode. So that is my y-axis. But my x-axis is not what I want. So here what I have is the voltage source. So this is the voltage source. But I want to do is I want to measure voltage across the diode. So therefore I'm going to change my x-axis. So I'll axis settings, x-axis. So I'm going to change the variable. So here there's a button called axis variable. So once I click this one, I can do the changes to my variable for x-axis variable. So x-axis variable I would use, so I will pick V1 diode 1. Alright, so now we have what we wanted to see. So you can see this is going from minus 10 to like 0.8 and so on. Right? So this is the VI curve. So you can, so this is the voltage across the diode, and y-axis what you have is current across the diode. So there are like zoom in buttons. So if you want, you can zoom in certain region and see what are the voltages and so on, and you can move them to different locations. So this one, you go back to the normal one and zoom area, that is what I picked. So maybe I'll pick this section so that this section will be zoomed in, so you can see how it behaves. Okay, so hope you managed to get it done, and see you in next video.